Tonight's video looks at phases of the moon and eclipses. These are your properties of the moon notes. We're going to start with moon phases and then move on to solar and lunar eclipses. So our first key piece of information is that the moon doesn't make its own light. The only light that we see from the moon, or moonlight, is reflected sunlight. So the moon only reflects light from the sun. Right? It doesn't make its own light. It's not like the sun that produces its own light. And this is important because the moon phases are the changes in how the moon looks depending on how much of the sunlit side we can see. So the sun always lights up half the moon, just like it always lights up half the earth. And depending on where the moon is in its revolution around the earth, we see different amounts of the sunlit side. So the phases are changes in appearance due to the moon's orbit of the earth, and we see different amounts of the sunlit side of the moon. And this diagram kind of explains this a little bit more clearly. Right? Here's the sun over here on the left. Here's the earth in the middle. Right? Again, half of the earth is lit up. So it's daytime on this side. It's nighttime over here. And these inner circles show different positions of the moon around the earth. Right? So it's not in all places at once. It's only going to be in one of these places at any time. But if the moon was, say, at this point in its orbit around the earth, from Earth, we can't see any of the sunlit side. This white side is what's lit up, right? That's the side facing the sun, but it's all facing away from the Earth, right? Over here, we can't see any of that sunlit side. We call this the new moon. As the moon orbits, now from Earth, we can see a little bit of this sunlit side over here on the right side, and that's our waxing crescent. As we keep going, we get what we call our first quarter over here. Right? Looking up, you can see half of the sunlit side. It looks like this. It's called the first quarter because you are a quarter of the way through your orbit. Then you have what's called a gibbous moon. This is when it's more than half lit, but not all the way. So waxing gibbous here. And then over here, we have finally our full moon. Sunlight lights up this part of the moon. We can see the entire lit side from the Earth over here. And then we have waning gibbous, last quarter, waning crescent as the moon continues to move around the Earth and we go back towards being a new moon. So notes for this, we've got waxing and waning. All right. So the moon is waxing, means the moon is capitalized because we're talking about our moon. All right. So the moon is becoming more lit from Earth, or when viewed from Earth. And in a waxing moon, the right side is lit. And then we have what we call a waning moon, and the moon is becoming less lit when viewed from Earth. And in this, the left side is lit. And then we have what we call a new moon, is we can't see any of the sunlit side, right? And full moon, you're welcome to write in your notes as well. That's when we can see the entire lit side of the moon. But that's kind of obvious. We know what a full moon is. All right, so those are phases of the moon. And we're going to do some demonstrations about that in class tomorrow and have some people be the sun and some people be the moon. And that, I think, will help us kind of illustrate what all this stuff is. So our next property of the moon are eclipses. And so an eclipse occurs when the sun, moon, and earth line up exactly. So these three objects are exactly lined up. They're not at all off, a little high, a little low, or anything like that. And there are two main types of eclipses. We're going to talk about each: solar eclipses and lunar eclipses. So we're going to talk about a solar eclipse first. And this occurs when the moon gets in between the Earth and the sun, and it blocks sunlight. All right? Think about if someone is standing between you and the TV screen, they're blocking some of the screen, right? It's just like that. The moon is in between the sun and the earth, and it's blocking some of the sunlight. Now, as you can see in this diagram, there are some parts where the moon blocks all the sunlight, this little triangle here, and other parts where it only blocks some of the sunlight. And these are different parts of our shadow. This little triangle here is called the umbra, and this is the area of total shadow. No light gets through. This would be if somebody was standing directly in front of you. You couldn't see any of the TV. That would be, we would consider that to be in the umbra. Total shadow, we can't see anything. The area around it is called the penumbra. It's the area around the umbra of partial shadow. Some light gets through. All right? This umbra would cause a total eclipse, and this penumbra would cause a partial eclipse. And it's easy to remember which one does what. Penumbra, partial eclipse. They both start with P. So if you lived right here where my mouse is, right, some of the sunlight would come straight in and hit you, but the moon would be blocking some of it. So you would see the sun kind of partially covered up by the moon. And a solar eclipse looks like this. This is a total solar eclipse. The moon is totally in front of the sun, right? And you can see some solar flares on the sun's surface. It's pretty cool. A partial eclipse, the moon would only be blocking off part of the sun. So that's a solar eclipse. The other type of eclipse we can have is a lunar eclipse, and this is our last one. So we have a lunar eclipse, and this is when the Earth is in between the sun and the moon, and it blocks sunlight from the moon. Right? Again, we've got an umbra, an area of total shadow, and a penumbra, an area of partial shadow. So if the moon is in the umbra, we get a total lunar eclipse. If the moon is in the penumbra, we get a partial lunar eclipse. Now what this would look like is it would almost kind of look like phases of the moon, but instead of taking place over a month as the moon slowly orbits the Earth, the lunar eclipse happens within a couple of hours. And we'll watch some videos of this in class, kind of show you what it looks like, but a total lunar eclipse actually ends up looking like this. It actually looks red, and we'll see that the Earth's atmosphere bends some red light around it onto the moon. So it doesn't end up looking totally black. The Earth's atmosphere bends some red light around and makes the moon glow orange. So pretty cool. We'll do some demonstrations with this. We'll get up and walk around in class tomorrow and show how these things will be related to each other. Make sure you write a summary and fill out the survey so I know what questions you have, and I will see you in class tomorrow.